Hi, welcome to Unit 4.0 gases video. This is part 1 of 2. In Unit 4, we're going to focus on the behavior of gases and ways to predict them qualitatively and quantitatively. So in part 1, we're going to just really focus on some soft skills, particle diagrams, and properties of gases, defining those. So that will sort of help us in the later video with understanding some of the content. So particle diagrams. Particle diagrams you have seen before. They are the models or drawings that we use to represent matter. And we do that because matter is so hard to see. It's like they're too small. And they're helpful because they help us to explain or describe what's happening. So here are some examples of particle diagrams. You will see that in this case, these are particle diagrams showing differences between pure substances, and specifically elements and compounds, and mixtures. These particle diagrams are showing the difference between solid liquids and gases, and this particle diagram is showing what happens when you dissolve salts, specifically NaCl, in water, how the water molecules will rearrange so that the partially positive parts will be around the anion and the partially negative parts of water will be around the cation. So all of these particle diagrams have one thing in common. You'll notice that the atoms and molecules are drawn as circles, and that's because that's the best shape to sort of describe what an atom or particle looks like. It's the simplest shape. So with that being said, let's sort of test our understanding of particle diagrams. Because you've seen them before, we can dive right into the CFU. Which image accurately depicts a particle diagram for CH4 or methane gas? Pause the video now, and when you press play again, the answer will be revealed. Great, the answer is E. So let's look at why the other answers are wrong. A is the molecular model. It's not a particle diagram. Remember, for particle diagrams, we use circles to sort of describe the atoms or molecules. B is a Lewis dot structure. It's not a particle diagram. C and D are both particle diagrams, but C is of a liquid and D is of a solid. So how can we tell the difference? Well, notice, first of all, that solids and liquids do not take up the entire space of the container like gases do. You may also notice that solids have this sort of regular shape, like all the particles are close together and they have a regular shape. Liquids, the particles are close together, but they don't have a regular shape. And so as a result, a solid will have a fixed shape because they are arranged in a regular fashion, and liquids will not have a fixed shape. They'll take on the shape of the container, but they won't take on the volume of the container. So sort of to summarize particle diagrams for the phases, they help us to explain the properties of solid, liquid, and gas. Solids having fixed volume and fixed shape, meaning the volume and shape of the solid is going to be the same no matter what container you put it in. Liquids have a fixed volume, meaning that the volume of the liquid is going to be fixed no matter what size container you put it in. So for example, if you have 1 liter of water and you put it into a 2-liter container, you still will only have 1 liter of water. The shape, however, of liquid is not fixed, so it will take the shape of the container. Gases do not have a fixed volume and they don't have a fixed shape. And that is to say, if you have 1 liter of gas and you put it into a 2-liter container, the volume of the container is going to be 2 liter. And that's important because sometimes in problems, they won't say the volume of the gas is this, but they'll say the volume of the container that it's in. Lastly, the shape is not fixed because it takes particles of gas particles spread out throughout the entire container, so they're going to take up the entire shape of the container. It's also important to note that gas particles move really fast and in irregular directions, and that sort of is one of the reasons why gases have certain properties that we'll look at in a moment. So what are these properties of gases I'm talking about? Moles, volume, temperature, and pressure. We're going to go through each one of these one by one, and we're going to use particle diagrams to sort of explain what they are. So let's start off with moles. Moles measures the amount of gas. And another way of measuring the amount is mass. So sometimes you'll be given moles, sometimes you'll be given mass. But moles are what we use in the gas equations that you'll see later on, because they're more ubiquitous since they're actually telling you how many particles you have. Whereas with mass, you don't know how many particles you have because that's going to depend on the molar mass of the particle. All right, so with that being said, we have 2 particle diagrams here of flask, one on the left, one on the right. Which flask has fewer moles of gas, and how do you know? Great. The one on the left has fewer moles, has less moles, and the one on the right has more, and you can tell because you can count the number of particles. So for particle diagrams, if you want to show something having fewer moles of something, you just draw less dots or less circles. Volume is the space occupied by a substance. I believe you're going to have to change that in your handout. It should say substance, not gas. But since we're dealing with gas, space occupied by gas. And remember, the volume of the gas is equal to the volume of the container. So the gas is going to spread out throughout the container. And so if you have a 1 liter container, you have 1 liter of gas. You have a 5 liter container, you have 5 liters of gas. It's also important to note, since they're really spread out, that it's mostly empty space. That's the reason why sometimes when we think of gas, we think of them as like empty, but it's not empty. There are particles there, but most of the space that's occupied by gas is empty. Okay, so if volume is measuring the space occupied by a substance, which of these particle diagrams shows a gas with greater volume? Right, the one on the right is the one with a greater volume or larger volume, and we know that because the size of the container is bigger. Even though in both cases you have the same number of moles, you still have 4 particles of gas on both sides, the volume is still larger because the container is larger. And remember, volume of the container is equal to the volume of the gas. Okay, let's try a CFU now. So in these CFUs, you're going to be looking at samples of helium gases in both sample A and sample B, and you're going to determine which one has, in this case, you're going to determine which one has more or less mass and volume. So compare them, see which one has more mass or more volume, and explain your answer. Pause the video now. When you press play again, the answer will be revealed. Great, so both samples have the same amount of mass because you can sort of just count up the number of particles and you see they have the same mass. And the reason why they have the same mass is because they're both samples of helium gas. If it was helium gas in sample A and helium and neon gas in sample B, they would not have the same mass because they don't have the same molar mass, meaning one helium atom weighs less than one neon atom, so you couldn't compare them. But since both have the same type of substance in both sample A and sample B, you can compare them. So the masses are going to be the same because it's the same number of particles and they're the same type of particles. Lastly, sample A has a smaller volume because it's a smaller size container. All right, so in this case, what you're going to determine is, sorry about that. So we're going to try it again. Which sample has more or less mass or volume? Pause the video now. When you press play again, the answer will be revealed. So again, the sample A this time has more mass because it has more particles, but it has a smaller volume because it's a smaller size container. Last one like this, again, compare them for which one has more or less mass or volume. Okay, in this case, A has a smaller mass because it has fewer particles, but they have the same volume because both containers are the same size. Okay, so we just explored using how to use particle diagrams to determine mass and volume. Let's move on to temperature. Temperature actually measures how fast particles are moving, and the faster the particles are moving, the higher the temperature. And that's important because a lot of times we think of temperature as heat. No, that's not really the case. It's really just measuring how fast the particles are moving. So the faster they move, the higher the temperature. So let's take a look at these two examples. Which one do you think, just from looking at the particle diagram, we'll talk more about later, which one do you think is moving faster and therefore has a higher temperature? Great, so the one on the left is moving faster and has a higher temperature, and if you got it, it was because they have what we call these like whooshies. So the lines at the end of the particles are called whooshies, and the longer they are, the faster they're moving. Since these have longer whooshies, they're moving faster, and this one's moving slower because it has shorter whooshies. The last property we're going to look at is pressure, and this one is so important because it really kind of helps you make sense of a lot of things. Pressure is measuring the force and frequency of collision with which the gas particles hit the walls of the container. So the harder and the more frequent the particles hit the walls of the container, the greater the pressure. And we can sort of see that like gas particles are moving really, really fast. They're bouncing into each other, but they're also bouncing into the walls of the container. And that's what creates the pressure. Okay, so let's try the CFU now. Let's test our understanding on temperature. And so temperature measures which one of these. Take a moment to read them, pause the video, and then when you press play again, the answer will be revealed. Great, it measures how fast the particles are moving. A would measure mass or moles, C would measure volume, and D would measure pressure. Okay, which sample has a higher pressure? And you need to explain. So a good one with this one, you want to think about which two aspects of the sample, which things are different, and how would that difference affect how hard or how often the molecules, the gas particles, hit the walls of a container. Because remember, that's what pressure is measuring, how often or how hard. So take a moment to sort of think about it. Which one do you think would have a higher pressure? And consider that they're both the same gases. Great, sample B would have a higher pressure because it has more particles. And the more particles you have, the more often it will hit the walls of the container. So that means it would have a higher pressure. All right, let's try 7 now. Which sample here do you think will have a higher pressure? Again, think about the differences and how that would affect how often, how hard the particles hit the walls of the container, and use that to help you answer the question. So which one do you think has a higher pressure? Great. Sample A is because the particles, they have longer whooshies, so they're moving faster. So particles that move faster are going to hit the wall of the container with more force. So that means that sample A would have a higher pressure than sample B. So this is sort of like sample A is the balloon that's been heated up, and sample B is a balloon that's been cooled down. A would have a higher pressure. Okay, so that's it for part 1. We are going to move on to part 2.